Hello. Today we're going to be discussing geometric sequences. We're going to start off by comparing and contrasting arithmetic and geometric sequences. How are they alike? How are they different? So let's consider that. This is a later video in the sequences and series set of videos. So we would have already discussed arithmetic, geometric, well, no, not geometric. We would have already discussed arithmetic, recursive, and alternating sequences. Now we're going to look at how arithmetic and geometric sequences are alike and how they're different. Well, they both start off with a first term. With arithmetic sequences, you add a common difference to each term to get to the next term. With geometric sequences, you start with the first term, and then you multiply a common ratio to get to the next term, and you'll be multiplying each term after that by the common ratio. You can find any term of an arithmetic sequence by using this formula. A sub n equals a sub 1 plus parentheses n minus 1 parentheses closed times d. D is the common difference. You can find any term in a geometric sequence by using this formula. A sub n, any term, equals the first term, a sub 1, times the common ratio to the n minus 1 power. N is whatever term you're looking for. If you're looking for the seventh term, n will be 7. Now, if you decide to add all the terms together, you can use this formula for an arithmetic sequence. Sn equals n over 2, parentheses, a sub 1 plus a sub n, parentheses closed. And if you decide to add a bunch or a few of the terms of a geometric sequence together, you can use this formula. S sub n equals a sub 1 times parentheses 1 minus r to the n power over 1 minus r. Geometric sequences are special. Under certain circumstances, you can add an infinite number of terms of a geometric sequence together, which will turn them into an infinite series and actually come out to a number answer. It's the most amazing thing. You can do that if your r is a proper fraction, either positive or negative. And the technical way we say that is that the absolute value of r is less than 1, which means r is located on the number line between -1 and +1, which makes it a fraction, a proper fraction. To find the sum of an infinite number of terms in a geometric sequence, which means you're finding an infinite geometric series, use this formula. The first term divided by 1 minus the common ratio. That's it. Hurrah! Off we go to geometric sequences. But you need to memorize those formulas. As long as you're working with series and sequences, you're going to need them. There, I have spoken. Now we're going to try to find a common ratio. We're going to do this by finding two adjacent terms. We're going to take the later term and divide it by the earlier term. In this case, we're going to take a2, that is the second term, and divide it by a1, the first term. -10 divided by 2/3. Well, this is only going to be -10 divided by 2/3. and you know how to divide fractions, and if you don't, your calculator will do it for you. I'll take -10/3 and multiply it by the reciprocal of the second fraction, which is 3/2. The 3's will cancel. The 2 will go into 10 5 times. And so our common ratio will be -5 because the negative sign was already there. All right, remember that R is the common ratio. We're going to take each term of our geometric sequence and multiply it by the common ratio. We did it! All right, now let's find the nth term. In this case, we're going to find the 9th term. So n will equal 9. So a sub 9, is going to equal -2, which is the first term, times the common ratio, which is going to be -6 divided by -2, to the 9 minus 1 power. This is going to equal -2 times 3, the common ratio is 3, to the 8th power. First, remember order of operations. Please excuse my dear Aunt Sally. We have to find the exponentiated expression first, so 3 to the 8th power is going to be 6561, and then multiply that by -2. And our 9th term is going to be -13,122. All right. Now we're going to find a term again. First, like before, we need to find the common ratio. We can see very clearly what the first term is. We're going to take the second term, 7/81, and divide it by the first term, -7/243. And that will give us 7/81 times 243 over -7. 81 will go into 243 3 times. -7 goes into +7 -1 time. And so our ratio for such an ugly set of fractions is really just the number -3. So to find the 8th term, we'll take the first term, which is admittedly kind of ugly, -7/243 times -3 to the 8 minus 1 power, which is 7. So we'll have -7/243 times -2,187. 243 goes into that. -9 times. -7 times -9 is -63. So our 8th term is going to be, positive 63, because negative times negative is positive. Now we're going to find the sum of the first 10 terms of a geometric series. That is, each of these terms was part of a geometric sequence. Then we decide to add them, which makes them a series, a geometric series. Notice that the first term is 3, and the common ratio is going to be 12 divided by 3, which is 4. So we're going to use this formula in order to find the sum of the first 10 terms of this finite geometric series. It's finite because it has a definite beginning and ending point. We'll take the first term and multiply it by parentheses 1 minus the common ratio to the 10th power, because we're finding the 10th term, over 1 minus 4. Always exponentiate first. Well, work in parentheses first, right? Then exponentiate first. Then you multiply and divide. Then you add and subtract. That is order of operations. So we'll have 3 parentheses, 1 minus 4 to the 10th power, over negative 3. And so S10 will equal 3 times, well, yeah, let's drag the denominator over. We'll have 3 over negative 3, parentheses, 1 minus 4 to the 10th power, and that will give us negative 1, times parentheses 1 minus, what is 4 to the 10th power? All right, we're going to have to put this in the calculator and find out. Next line. We're going to have negative, because that's negative 1, negative parentheses 1 minus 1, 0, 4, 8, 5, 7, 6. Really big number. That's going to equal negative parentheses negative 1048575. And of course, negative times negative is positive, so now we know the sum. The sum is going to be positive 1,048,575. Had to take a closer look. Ta-da! We have now mastered geometric sequences. Easy formula, notice, the formula isn't too bad, but the numbers you get are terrible. Yes, it is a difficult calculation. Talk to you later.